Welcome to our presentation. Our project is titled Bayesian Network to Diagnose COVID-19 Infection, and this project was prepared as part of our machine learning subject. Over the next 6 minutes, we invite you to stay with us as we explain how we developed our project, how we analyze the data, and how our model works. Trust us, this presentation will be short, clear, and highly informative. In the next 6 minutes, so sit back, relax, and join us on this exciting journey. This is Kavipriya. My team members are Kausalya, Lavanya, Manoj Vishnu, and Marimuthu. Let's start. Introduction. COVID 19 is a highly contagious disease and early detection is extremely important. Symptoms vary from person to person, which makes manual diagnosis challenging and unreliable in many cases. This is where machine learning becomes useful. It helps predict the likelihood of infection based on available data. In simple terms, our system combines data, probability, and intelligent predictions to support COVID 19 diagnosis. Problem statement. COVID 19 symptoms are often uncertain and overlapping, which makes manual diagnosis slow and inefficient. Relying on a single symptom does not lead to accurate predictions. Therefore, we need a probabilistic model that can diagnose COVID 19 effectively even when information is incomplete. Why did we choose a Bayesian network? It works based on probability, making it ideal for uncertain and incomplete data. It can easily handle missing symptom information. It clearly represents cause effect relationship, which is crucial in medical diagnosis. Now, let us move on to the coding part. We open Visual Studio Code and start implementing our project. Library imports. First, we import the required libraries. Pandas is used to read the CSV file and manage the dataset efficiently. PGMPY is used to create and train the Bayesian network model. Scikit-learn is used for splitting the dataset into training and testing sets. Logging is used to suppress unnecessary warning messages. OS is used to suppress unwanted system level outputs and to check file paths. Defining the Bayesian network structure. Next, we define the Bayesian network structure. In the Bayesian network, we define edges between symptoms and COVID 19. This represents how the presence of certain symptoms influences the probability of COVID 19 infection. In simple terms, we model how different symptoms contribute to the likelihood of COVID 19. Loading the CSV dataset. After defining the network structure, we first check whether the CSV file exits at the specified path. If the file exits, we load the CSV file using pandas. We print a few sample rows to verify that the data has been loaded correctly. This step ensures that the data is properly created and available before training the model. At the end of the presentation, we also show the final CSV file path, training the Bayesian model. Once the data is loaded, we train the Bayesian network using the Bayesian estimator. Patient diagnosis. We provide evidence, which means the patient symptoms. Based on this evidence, the model calculates the probability of COVID 19 infection. Inference using variable eliminations. We use variable elimination, which is an efficient inference technique. This method avoids unnecessary computations and suppresses unwanted output during predictions. Predictor and accuracy calculation. Next comes predictions and evaluation. For the test dataset, we use each patient symptoms to make predictions. These predictions are stored in a list. To evaluate performance, we compare the actual values with the predicted values. The CSV file is loaded. The dataset is split into futures X and target Y. We perform an 80% training and 20% testing splits. The training dataset is combined and used to train the Bayesian model. The test dataset is used to make prediction and the accuracy is calculated. Finally, the overall accuracy score is displayed. Individual patient predictions are also shown, indicating whether each patient is predicted as COVID 19 positive or negative. Data set description. This data set is prepared based on WHO COVID 19 guidelines. The symptoms are used as input features, binary values are assigned, where 1 indicates the symptom is present and 0 indicates it is absent. Each row in the data set represents a single patient record. Technologies used. For this project, we used Python programming language along with libraries such as Pandas, PGMPY, and Scikit-learn. The development was done using Visual Studio Code. System architecture. First, the dataset is collected. Next, data pre-processing is performed. Then, a Bayesian network model is created. Finally, prediction and accuracy evaluation are performed to measure the performance of the system. Advantages. Effectively handles uncertainty in symptoms. Works well with medical and healthcare data. Easy to understand and interpret. Supports early diagnosis of COVID 19. Disadvantages. Accuracy depends on the quality of the dataset. Requires proper data preparation. Small datasets may reduce predictions accuracy. Early detection of COVID 19 is very important. This system helps doctors in decision making. It reduces manual diagnosis effort. It is useful for healthcare and medical applications. Code implementation. First, we import the required libraries. Then, we create the Bayesian network model. The dataset is loaded from the CSV file. The model is trained using the Bayesian estimator. Next, predictions are generated. Finally, the accuracy is calculated. Output. The overall accuracy of the model is displayed. Each patient's prediction is shown separately. The final output clearly shows COVID 19 results. Conclusion. Bayesian network is effective for COVID 19 diagnosis. It handles uncertainty in symptoms efficiently. The performance can be improved using larger datasets. Thank you so much for watching our video till the end. I really hope you enjoyed it and understood everything we shared. Your support means a lot and it encourages us to make more content for you. Stay tuned for more.